recording. Okay, so we're talking about interactions. So we learned a little bit about variables last week, and we learned about some system variables this week. And now we're going to use what we learned to create interactions. So we're going to create a system where our self-portrait can react to user input, which in JavaScript we refer to as events. And so using code, one of the main reasons that we want to use code rather than using software like Photoshop or InDesign or something like that to create our designs is that we can make things that are interactive, we can make things that are animated. We have the ability to add this component of interactivity and motion into our designs that isn't really available otherwise. So interactive design gives the user the ability to change the design that they see based on different inputs. Those can be small changes, they can be large changes, and we as the designers or artists have the ability to kind of control what the user is able to change. So that means that we have to kind of think about how the user is going to interact with our project, and we usually have to give them some instructions and think about how it's going to work. So when we're using JavaScript, we use something called events to determine when a user interacts with the program. Events are things like when they move the mouse or click the mouse or type on the keyboard, or if they're using their phone, it may be touching the phone screen or rotating the orientation of the phone. All of those things are different events that the software can record from the hardware of our computer or our device, and then we can change the art based on those events. So we already looked at a really simple version of an interaction, just drawing a line. We did that yesterday, so we can just take a look at this again. So we made this really simple program to just track where the mouse is and draw a line between the mouse points to create an interactive program. So it's not very sophisticated, but you could imagine how this might eventually turn into something that we could use to create our own software, like our own Photoshop or something like that. So another thing that we can do is detect when the mouse is pressed. And this is a slightly different type of event. This is, oh, I need my, whoops, let me open up my pen tool. So the position of the mouse is an event that's changing constantly, or it's not always changing, but it's always being registered. So the computer is always looking at it. So there's these two different types of events. There's like some events that are just continuously happening. So like if this is our mouse, it's always moving around. And if this is time, and time is this linear scale going forward, this mouse is always moving around. It's moving up and down, or maybe it stays in one place for a while, but this value is always changing. And so mouse X is always changing along with whatever the mouse is. Mouse press is when we actually click the mouse. So when we click down the mouse, that's a moment in time. And mouse press is actually when we click and then release the mouse. So that's an event that starts here when we press, and then it ends, somewhere over here when we release the mouse. And so when both of those things happen, the computer, records those events, and that's called a press. And so this type of event is not constantly changing. It's an event that happens at a specific time. And so in order to capture that, we need to use a special function. So we're going to use a function to capture when the mouse is clicked. We can, one thing that's a little confusing, and we'll look at different versions of this, is that we can see if the mouse is clicked. So if we think about time, again, if our mouse is not down, that might be like from this time to this time, and then the mouse might be down here, and then once it's released, now the mouse is up. So this is up, this is down. And so that value is always being registered. So the computer is always looking at, is the mouse up or down? But then when it changes from up to down, that is a specific event in time. So when things are changing, they're usually captured by a property or a variable like mouse X, or we'll see there's one called is mouse pressed, or I don't know, that's actually probably not right, but it's something close to that. And then these need to be special functions like setup and draw. So this one is going to be function mouse pressed. And so we'll see how those look and work when we put them into our program. Okay, so in this case, I have the same program. I'm just drawing a line, but notice I have a new function in there. And so I've also added a little bit of functionality. So when I click the mouse, sorry, um, when I click the mouse, I redraw the background. And so it covers up the previous line that's been drawn. So it looks like it's erasing, but all it's really doing is covering up what's been drawn before. So that's one functionality. You can do lots of different things, but that's what that looks like here, is we have this function mouse pressed, and then we redraw the background in there. So we can edit this code here to add transparency, and this will change how it looks. So it doesn't completely get rid of the previous line, but it's sort of, since it's using transparency, the background is a little bit see-through, so we can see older copies of the line, but as we continue to click, eventually they disappear. So in this program, notice we have an extra function. We have the function setup, which does what it normally does. We have our function draw, which is where we're drawing our line. And then inside our function mouse pressed, we're using the background function, which just draws the regular background. So this function mouse pressed only occurs when I press and release the mouse again. So I don't know if you can hear my mouse, but right now I'm clicking the mouse. Oh, actually, it didn't wait for me to release. Huh. So I guess mouse press is just as soon as I press. Maybe there's a different one. Oh, I think mouse clicked is what I'm thinking of, actually. I think mouse clicked means it has to be pressed and released. So let's try mouse clicked. Okay, so now if I click, I'm holding the mouse down and nothing's changing. And then when I release, that's when it draws the background. And I think there's also just plain mouse released. So yeah, this does the same thing in this instance where when I release the mouse, that's when the background is covered. So there's a few different functions there. These are all under events. So let's go over to the P5 reference for a second. So p5js.org/reference. And these are all under this events section. So you can see all the events associated with the mouse. So there's the mouse X, mouse Y, P mouse X, P mouse Y. We can also look at where the mouse is in the actual computer window rather than just inside of our sketch if we want to know where the user is on their own computer. There's a mouse button. Mouse is pressed. That tells us whether the mouse is pressed or not. Then we have these functions. So we know these are functions because they have parentheses after them. Mouse moved, mouse dragged, pressed, released, clicked, double clicked, mouse wheel. So if you have a scroll wheel on your mouse. And then these are actually related to the mouse, but not events that we need to know. There's also keyboard events. There's not as many of these, but there's obviously a lot of keys. So all the keys are stored in these key and key code values. And then for your phone, there's device orientation or acceleration events if you're, shaking your phone or rotating it. And there's also a touch events for your phone or tablet. So let's continue. So again, just like setup and draw, mouse press is a function that we write what we want to happen, but P5 is actually calling it. And we'll talk more about functions a little bit later in the semester. For now, we're just kind of like glossing over how they actually work because they're kind of complicated, but we're just using the ones that P5 made for us. So we can also use mouse dragged, which detects if we click and then drag the mouse. And we can also use key pressed to determine whenever a key is pressed. So in this example, instead of using draw, I'm using mouse dragged. And instead of using mouse pressed or mouse clicked to draw the background, I'm using key pressed. And so when I'm doing mouse dragged here, I'm drawing ellipses instead of lines. And if I hit a key on the keyboard, that will get rid of my background for me. And so there's a lot of cool stuff you could do with this. You could use different keys to change the colors of your drawing application. You could you could change the width or the size of the circles that you're drawing or the type of shape that you're drawing. So there's a lot of different things you can do with these events. And so just go over the code. So here I have function mouse dragged, and I'm capturing the x value, I'm capturing the y value, and then I'm actually doing the size based on the position of the mouse. So we don't really have to worry about that right now. I'm just kind of doing something to make, that's why the circles are smaller up here and larger down here, because I'm just adding them together just so we can kind of see the differences in the different areas of the sketch. And then down here, I have another function, key pressed, and we're logging the key code. I don't think we have to worry about that quite yet, but we are drawing the background. So the key code is like which key it is. And actually, we might as well take a look at that. So if I open up the console, you can see all these numbers, and that's what key is being pressed when I press a key. So if I hit space, that's 32. If I hit A, that's 65. If I hit 1, that's 49. So our computer has numbers associated with all of our keyboard keys so that we know which one is being pressed. And there's an easy way to figure out what those are. If you go to keycode codes.info, I think that's the website. Oh, huh. It says it's blocked. Okay, let's try keycode.info. Okay, there we go. So yeah, this will tell you the number for any key that you press. So A is 65, space is 32, 1 is 49, A is 65, B is 66, C is 67. So there's this big like table, or actually we can actually click on the table right here and see all of the different key codes. So the first big group is all these kind of like modifier keys, tab, enter, shift, control, alt. Um, etc. And then we have the arrow keys and some other keys, and then we get to our digits up here in the 40s, and then some punctuation characters, and then finally we get to the letters up here, 65 through 90, some more modifier keys, and it keeps going and going for all the other keys on the keyboard. And so that's how we know which key is being used on the keyboard. Okay. So we've talked about what we can do with our events, what types of events there are, but now we want to look at how we can actually change things in our sketch by using those events. We're going to look at the self-portrait a little bit and think about things that we can change in the self-portrait using interactivity. So one of those things is position. Okay, so if we're interacting with the position, here I'm in this little example, you can see the value of the mouse X, as I move across the canvas. And then you can see the circle in my example moving along with the mouse. So this is probably the simplest version of looking at interactivity because the position of the mouse is directly correlated with the position of the shape that I'm drawing. So that's probably the easiest one to kind of like figure out essentially is just mapping the mouse directly to the shape. There's other things that we can do that don't line up as easily visually, but let's look at this example first. Oh, whoops, I didn't mean to click on there. And so we can look at it in here, but then I'll actually add it into my own self-portrait just as an example. So here I have like a really simple self-portrait just for the example. And you can see that I'm capturing mouse X and mouse Y. So I'm going to close this. So I have mouse X and mouse Y up here. And so I'm using those as the X and Y for the self-portrait. So I want to show how this would look in my actual self-portrait. So I'm going to go over here where I have the self-portrait. And so in this self-portrait, I think I did all of my variables, hopefully. Yeah, I did all the X's and Y's. And so the nice thing about that, and part of the reason we did things in this order, is now that I have all my X's and Y's set up, right here where I'm setting X and Y, I could set these instead of just width over 2 and height over 2 to center my self-portrait. I can set these values to the mouse X and mouse Y that are changing. So there's a couple things that I have to change here. You can see that right now I'm only using the setup function. So if I collapse this, I only have the setup function. So I'm only drawing this once. Remember, setup only runs once. And so if I want this to move with the mouse, I have to keep drawing it so that it draws while the mouse changes. Um, so what I can do is just add in the draw function. And I'll do this kind of in a similar way to what I was just showing Levita with her book in her self-portrait. So first I'm going to close the part of my setup function that I only want to do once, which is really just the create canvas here. Because I want to keep drawing the background so I'm not, drawing multiple copies of my self-portrait character. So then I'm just going to add in the function draw here and that little open curly bracket. But since I closed this setup function here, this curly bracket that I have down here at the bottom is still left over from how I had the setup function before. And you can see it still matches the new curly bracket. So setup collapses nicely by itself, and now draw connects all the way down here. And most of your text editors, they'll show you that. So when I click on this curly bracket, I can see that it aligns with that curly bracket up there. So that looks good. So if you make a mistake there, you'll probably get an error. So you might see something like this, where it says unexpected expected end of input. And that basically means that you just you are missing an ending curly bracket to one of your functions. So let's go ahead and put that curly bracket back in. Okay, so now our self-portrait is still in the middle, but now instead of x equals width over 2, I can say x equals mouse x. And so now our self-portrait moves along with my x value. So that's pretty cool. I could make this into like a little video game where, you have to move the self-portrait to avoid like some falling rocks or something like that. That might be kind of fun. And I can also do the same thing on the y value. I can say y equals mouse y, and now my self-portrait will go wherever my mouse goes. So that's pretty fun. That gives me a lot of different possibilities for how to work with the self-portrait. So that's one type of thing where I talked about where there's continuous movement. Every time I move the mouse, the self-portrait is changing. But I could also do movement that's not continuous. So let's return this to the way it was. And now I'm going to do an example of using an event that happens in time. So I'm going to use function, and I'm just going to say key pressed. So I'm going to use my keyboard for this one. And what I'm going to do is just add to x. I'm going to say x plus equals 10. And so now if I hit a key, oh, this one is tricky because I have to click on the canvas first because the browser, it doesn't have focus. My keyboard is still focused over here. So I have to click on the browser first and then hit a key. And oh, whoa. Okay, this is actually a good thing to go over. So I'm not getting any errors, but it's not doing what I want because I forgot to do something. So even though I'm saying x plus equals 10 here, we can actually see that happening because I can log x. Okay, so I'm gonna hit a key and it's 310. So it's taking width over 2 and it's adding 310, but it's not moving because I'm rewriting x here. So let's move all of these variable declarations. I'm going to copy those. So I hit Control C, and I'm going to put these in my setup function. So these are actually things I only need to do once in my program to establish the position and size of my character. And so now when I hit the keyboard, now my self-portrait is moving. So that's pretty cool. And you can see the number increasing over there. So I don't just have to have things that happen continuously. I can also have things that happen at specific events. And
Can I ask a question?
yeah, go for it.
Um, so like, can you have the eyes move along? I put it in the comments, but like, I don't think I explained it properly. Like, if you move the mouse, like just the eyes are moving.
Yeah, um, you can do that. You need some more variables for that. So I'll demo that real quick. So let me turn off this bit here. And so if I want most of my self-portrait to stay the same, but I want my eyes to move, then I need another variable. So where are my eyes? They're down here. Okay, so what I could do is I could say let I x equal mouse x, let I y equal, or let's just do the x. I'll just do simple. Okay, so this isn't going to work exactly the way we want it to, but I am going to show you guys a better way to do this pretty soon. But anyway, all I have to do is say x plus 65, which is kind of the default, or actually, let's just take that all the way out. We'll just say I x plus 65. So I'll just replace x with ix. So ix plus 65 and ix minus 65. Okay, so now my eyes will move with the mouse, but they'll still be offset from each other. So they're 65 pixels away from the center of them where my mouse is. So they are moving across the screen, but they're still staying, relative to each other.
What
Um,
if you want to limit it?
okay, so that's actually exactly what we're going to get into uh, in a few slides. So let's pause there, and then we'll come back to it. Okay.
Okay.
But that's a really good question. So yeah, it's something we'll cover in a second. Cool. So let's see. So yeah, let's keep going. Let's continue. Okay. So far we've only changed the position of like our self-portrait relative to the mouse, but we can also interact with other things. So we're going to look at using color for a second. And uh, yeah, we'll look at color for a second. So in this code, I'm going to run the code and you'll see what happens. So you can see the circle in the canvas. And if I move my mouse all the way to the top left, the circle is completely black. And if I move my mouse all the way to the very bottom right, now I get this like cyan, light blue color. If I go all the way up to the top right, it's completely green. And if I go all the way to the bottom left, it's completely blue. So why is this happening? Let's read through our code. So in our code, we see we're drawing, we have a black background, and then we have this variable r, which is just equal to 0. So that's just our red, and it's not doing anything. It's just 0. But now we have a variable b, or sorry, g, which stands for green, and that's our mouse x. So whatever our green value is being set by the position of the mouse. So we're actually translating this position value into a color value because both of those things use numbers. They just use different scales. So then we have the blue value, B, is set to mouse Y, and then we're using those values, whatever they are, to create our color. So we have red, green, and blue. And then down here, I'm just drawing an ellipse in the middle of the screen just so we can see what that color is. It's nothing particularly exciting, but we can see it there. So let's do a little text of those colors. So we haven't talked about text yet, but some of you guys have used it, and we'll use it soon. So I'm going to do some text, and I'm just going to say, oh, I guess I need all my. This is going to be trickier than I thought. I'm going to use some fancy syntax, but don't worry too much about this. So I just want to see what my R, G, and B values are as I move my mouse. And let's make this a little bit bigger. Okay. Oh, dangers. Yeah, there's a big, okay, so I need to round these values so they don't have decimal points. Okay, so now we can see those colors. So, and let's actually change the color because if they get dark, we can't see them. So let's do fill is white. Okay, so over here, you can see as the mouse gets closer to the top left, we have almost 0, 0, 0, although I can't quite get it there. I'm going to like negative. Anyway, you see the numbers are very, very low. As I go across the canvas and add, oh, whoops, shoot. Okay. Oh, I put this fill before I actually draw my ellipse. Um, Shoot. So let's take my ellipse code and put it up here. And now this should work. Okay, there we go. So yeah, when all those numbers are very low, we're not adding a lot to the green and blue. So the circle is basically black. We can't see it. And as I go down on the y value, that y number is getting bigger and bigger, and we're actually using that for the blue, which is why we get more and more blue. And if I go the other way, now the X is getting mapped to the green. So we have more and more green, but no blue. And then if we add both the green and the blue together, we get this nice cyan color. And so I can change these around. Like I can set something else for red. I can say red is mouse X. And so now both red and green will get bigger as I go over here. So now we get that yellow, the combination of red and green. And down here we get white because we have all three of them. And over here we still have blue. So we can use the position of the mouse or other events to change things that are not just related to the position. We can map that value onto a different value, which is this color value. But notice that I use 255 and 255 as the size of my canvas. So I kind of made it so that the canvas was the right size for the range of colors. Because remember, our color values have to be between 0 and 255. Um, and so this is kind of uh, uh, what Levita was asking is that I can uh, I can use the map function to constrain or add a range to my colors. So let's see an example here. So down here is my color scale. So 0 is black and 255 is white. But up here is the position of the mouse. And the canvas is bigger than the color scale. The canvas starts over here at 0 and it goes all the way to 600 here. And so what this function is going to let us do is it's going to let us translate between the x position, this range, and the color range that we want to affect. So if I have the x like directly in the middle at 300, you can see our color is directly in the middle of our color range. And so the map function is really, really useful for doing lots of different things, but especially doing stuff with interactivity. So here I have another example, but this time my canvas is much bigger, and I still get this like nice full range of color. And so we do that using the map function. So let me go back up a couple times. For some reason, my slides are going slow. I probably just have too many examples in this page. Okay, so going back up here, so before I had my canvas set up to be exactly the right size for my colors, but let's say I had it at 600. So now what you're going to notice is even though my red value and my green value are starting to go way, way above 255, the color doesn't change. Once I get past like here, since the colors can't go above 255, it just ignores anything above that value. So this second half of the canvas is just completely ignored. So that might not be the end of the world, but if we're going to create an interaction, we want to be, using the full size of the canvas that we have. And so I'm actually going to go back to my self-portrait now and do the example that we were just talking about and use the map function for the eyes. Because the map function is a little bit challenging just because it involves a few different parts. So let's look at it here again, and then we'll go over to the example. And actually, let's go to the reference as well. Let's look at it there first. So I'm going to go to the reference in P5 and type in map. And here we go. Here's the map function. So it takes a value and then it takes the beginning and end or start and stop of two different ranges that we want to set up. And then there's this within bounds optional value, which is just a Boolean that just says like don't go over the bounds of the second range, which is usually what we want. So I usually put that as true. Um, and so you can kind of see they have some examples here where I'm moving these two different circles with the mouse. One is bound and the other one isn't, and they're moving at slightly different paces. Oh yeah, because they're mapped to different ranges. So let's take a look at the code here, and then we'll do our own version. So with the map function, so we have map here, and then this is the value. So this is the value that's usually going to be changing. So that's our changing value. I think my whole computer is starting to get slow. I'm doing too many things. So then we have the first range here. So this is the first range. And a range is just a a set of values in between a beginning and an end. So 0 is the beginning, and width, or the width of the canvas, is the end of this range. And then the map function takes wherever this value is in this range. So if it's 0, it's just going to be, at the beginning. And if it's all the way at the width, it's going to be at the end. And if it's somewhere in the middle, it's going to say like basically what is the percentage between 0 or between the minimum and the max or the start and stop. And then it's going to map that percentage to my second range, which can be whatever I want it to be. In this case, it's a color. So it's 0 to 255. And so whatever the range of the mouse is here is it's gonna, do the same percentage over here. And so it doesn't have to be 0. So let's do another example real quick over here where we would say, you know what, I don't want it to ever be completely black. And so instead of mapping from 0 to 255, let's map from 100 on the green. So it's at least always going to be a little bit green. So now we see, even when I go all the way to the top left corner, it's at least a little bit green over here. We could also say we want it to go backwards. So maybe I want the blue to actually be in the top left corner. And so I can flip the range around. I can put 255 first, and I can put 0 second. Okay, so now we've got blue up here, and down here we see that green. So we can actually flip the range. It doesn't have to be in the same direction. Okay, so that's our map function. Let's put it into our example and see how that works. And size is our next thing, but we'll work on this first. Okay, so we're talking about uh, constraining the eyes. And this actually comes up in examples a lot because I usually have these eyes in the self-portrait, and you think like, well, how do I get them to stay in these like little glasses? So instead of just saying let x equals mouse x, what we can do is map mouse x to a range. So let's take this, let's comment this out for a second, and we'll say let I x, and now we'll use the map function. And so the value that's changing is mouse x, and the range of our canvas is 0 to width. And then the range of our eyes, that we're not quite sure. So it's probably, maybe about, I don't know, 20 pixels or something like that. So let's just try 0 to 20 and see how that looks. So okay, so now you can see the eye movement is constrained, but it's not in the right place because we're just using this range here. So we do need to adjust this a little bit. So we need to put it in the middle of our canvas first. So there's a couple ways I could do this. I can say width divided by 2 plus map. That probably looks a little confusing. I could also put it in here, but let's just add it on the second line. Let's say I x equals I x plus width divided by 2. So we're going to center this. Okay, so now I can move the eyes to the right. So that's pretty cool, but I can't really go to the left. So I can actually make my range go negative. So instead of going 0 to 20, let's go negative 20 to 20. Okay, so now I've got that full movement. Okay, so I've constrained the eyes to that area, but I can move the mouse all the way across the canvas, and so now I can get those eyes to work the way I want them to. Um, so hopefully that answers the question, and I'll leave that in there. I think that's pretty cool, so we'll stick with that for now. And let's continue. So we have one more type of thing that we can interact with, which is the size. And so just like the color, the size doesn't relate directly to the position of the mouse, but they are both dimensional things. So it may be a little bit easier to see like as my mouse moves farther away from the canvas, the size of this circle gets bigger. And that's another place where we can use the map function or we can do different stuff. So here I have an example where I'm just clicking and it just makes my circle bigger and bigger. Another thing I could do with my eyes, since we're doing stuff with the eyes, what if when I click, they get big? Um, so if I wanted to do that, I would need another variable. Um, And so let's say I would actually need this to be a global variable because remember for a click, I need uh, I need to have my value inside a different function. So let's make a variable for the size of my eyes. So I'm going to say variable eye size, and I'll set it equal to what it is in my example, um, which is down here. It's 50. So I'll set it equal to 50. And so let's put the eye size in here and just make sure that looks right. Oops. Okay, that still looks pretty good. So now what we can do is change the eye size if I press the mouse. So I'll add it back in my function mouse pressed, and I'll say eye size equals, let's say 100. Okay, so now if I click, the eyes get bigger, but they don't go back, right? Because there's nothing telling it to go back to its regular size. So let's add in a function for the mouse released. So I'll say function mouse released, and I'll say eye size equals, we'll go back to our normal 50. And so now if I click, I get these big eyes, but if I release, now we go back to 50. And so there's different ways of doing this, but this is pretty straightforward. This is pretty easy to do. And we could also change the color if we made a variable. Let's do that as well, just so you guys can see what that looks like. So our eyes are normally white, so we can use white as a variable as well. So let's say variable eye color equals white. And then I just have to replace the color variable into where I have the color here. Okay, and now I could change the eye color. So let's say when I click, the character is getting surprised. So let's say the eye color is yellow. And of course, when we release, we'll set the eye color back to what it was. And so there we go. We have these like flashing yellow eyes, and it kind of looks cool behind the glasses as well. Um, so yeah, there's a lot of different stuff we could do with that. That's just one example. All right, so let's keep going. Just get through this, but then I'll let you guys spend some time working on this. Um, oh, so in this one, I'm showing that you can kind of go the opposite direction. Uh, But really, we should use the map function for this. So this example is probably out of order maybe. So let's keep going. Okay, so this is the last bit. So just the last thing I want to talk about is the idea of meaningful interaction. So we've seen it's very easy to make colors change, to change the position of a shape, to change the size of a shape. But just doing that by itself is not really that meaningful. So what we want to do is basically create what we can call meaningful interaction. Um, and so to do that, we have to think about what would a user want to do to kind of, play around with our self-portrait. And usually when there's not a lot we can do here. We can't build like a whole video game where they can walk around and, talk to other characters and jump on things. We haven't learned quite enough to do something like that yet, but we can give some context. So giving some instructions is usually a good way to give context. So normally what I actually do is I make the self-portrait talk, and you can see in this example, I have like a mouth and I'm just like wiggling the mouth around. And so it's not that exciting, but it just gives the user something to do. Like if I wanted to, pretend that I was talking, I could just wiggle the mouse around and make my self-portrait talk. But since I've already done the eyes in that example, I'm just going to leave this as is. But there's nothing, when I open this page, there's nothing that says like you can do something here. So for this assignment, what's really useful is to add some instructions. So you can add some instructions directly into the project using text, but we can also add instructions into the HTML. So the last little thing I'm going to do is I'm going to go to my index.html, and I'm just going to add in a paragraph here and just give some instructions. Uh, so I'm going to say, and even here, I'm just going to kind of like give some framing for why you might want to, interact with this sketch. So I'm going to say, my, uh, you can move your mouse and click to make my self portrait look at I guess there's no reason they would be looking at the mouse, but I could also put like, maybe I'll put like a little image there. Look at the mouse and react. Okay, so I just want to give the user these really simple instructions so that they know that they can interact with the project. And the text is down here. It's kind of boring looking, especially on this black background. So let's make it look a little bit better. I'm just going to go to my CSS and just put a p tag here for text, and I'm going to say font size is let's say 2EM to make it a little bigger, and color is white, so it stands out against the black background. And let's say font family is, um, let's say cursive to make it look kind of cool. Okay. That doesn't look like cursive, but whatever, I'll take it. So you can move your mouse and click to make my self-portrait, look at the mouse and react. And then let's put something where the mouse is, just so it's not, it makes a little bit more sense. I'll just do that real quick. So let's see, what do I want to put there? I'll just put like a dot there and just like say it's a fly. And another thing I can do is say, I think it's no cursor. Okay, so yeah, if I say there's no cursor there, it'll actually hide the mouse. And so let's just draw our really simple fly. I'm going to say fly, and so we'll say fill is 0, and I'll just draw an ellipse at mouse X, mouse Y, and I'll make it really small so it's hard to see. Oh, that's not that hard to see. Let's make it like 4 pixels. Okay, so now the self-portrait can try to follow this mouse around, and I guess uh, just get surprised whenever we click for some reason. I'm not really sure. Maybe it could be trying to swat the fly, and I could do something with that, but um, I think that's good enough for now. I don't really need to make this 100% perfect. But anyway, this is basically what I would want to do with this. So I just want to, so for this one, uh, turning it in is pretty much the same thing as turning in the previous self-portrait, but in this case, since it is interactive, you are going to want to capture multiple states. So that may be a little trickier, but one thing that is kind of convenient is we can actually put our save function inside of a another event. So I'm already using mouse pressed and mouse released. So let's use a key press so I can actually get a few screenshots of my project to put into my post. And then we'll be almost done. So I'm going to say function key pressed, and I'm just going to save um, self portrait interactive.png. And I can make a few copies of this. I think it'll just add like a one to it in my downloads folder. So let's save one version of it, and then I'll click and I'll save another version of it. Oh, it looked like the first one didn't go through for some reason. Okay, and let's do one more down here, and I'll hit a key. Um, and so yeah, that should be pretty good for the documentation. And so I'm just gonna make my post real quick just to go over this. I know that you guys probably already know how to do this, and I'll probably stop doing this every time. But just to make sure everybody knows how to get their post up, so just go over to the Open Lab, make sure you're logged in, and then click the plus button here and choose a category. So for this one, we want assignment 4, interactive self-portrait. And so we can put in the title, my interactive self-portrait, or you can name it after, something that's special about the self-portrait if you want to. And I'm just going to do this real quick. I'm going to add in a gallery of the screenshots I took. So I'm going to click gallery, click upload, and go to my downloads. And there I can see the 3 screenshots that I took. So I'm just going to hold control and select all of those and click open. And that looks pretty good. And then I'll just put a little description here. So in my interactive self-portraits, the user can move a fly across the canvas with their mouse, and the self-portrait will follow with its eyes. Okay, and my code, and just add a quick link to the code that I used for this right here. Whoops. So I'm just going to select this text and hit Control K and Control V to paste in that link, and click open in a new tab and click enter, and I'll click publish. I should preview first, but even if I publish, I can always edit it later. So I'm clicking publish, and then I'm just going to go to view post, and there we go. That's pretty good. Looks like that works. And so yeah, that's all you have to do for this one. At some point I'll go over actually capturing a video for interactive projects, because I think that'll be just a useful thing for people to know about. But for now, just capturing a few different versions of the image is good enough. And yeah, this obviously could use some work. Like my self-portrait doesn't have any like mouth or nose or anything like that, but just as a quick example of something that you could do. And yeah, just that's the link. Just submit that on Blackboard. Okay, so that's it for me. I'm going to stop.